All right, so we're going to finish working on Chapter 4 with this last section, Section 4D. And we'll be talking about loan payments, credit cards, which is basically a loan, working with mortgages. We'll see another, maybe one or two formulas that'll help us make some calculations with respect to these payments and the interest that we have to pay. Now, this is my second time doing this video. Computer's just not having a good time when I try to create these. So what you'll notice is that the sheet is already filled out because this is my second time doing this. So let's just get some loan basics out of the way. For any loan, the principal amount is the amount that you borrow or the amount of money that is owed at any particular time. And on that money that's owed, you will have interest that's being charged. When you make a payment on a loan, these payments include all the interest you owe plus some amount that goes towards paying off the principal. And when you have a loan, the term is the amount of time that you have to pay back the loan in full. Now, credit cards are different than auto loans or mortgages because in a credit card, there is no term that you have to pay back. You just keep making those payments or minimum payments, and honestly, if you just make the minimum payments every time, it'll take forever to pay off the balance on a credit card. So let's take this situation. We're going to borrow $1,200 at an annual percentage rate of 12%. That $1,200 that we're borrowing is called the principal. And think about this, the annual percentage rate of 12% means that you're paying 1% interest on that principal balance per month. So 12% divided by 12, because there are 12 payments or 12 months in a year. So we can calculate the monthly percentage rate by taking the stated percentage rate, annual percentage rate, and dividing it by 12. So what we're doing is we're paying 1% interest every month of that loan. At the end of the first month for this particular loan, I would pay $1,200 times 1%, which would be $12 in interest. If I only paid the interest that first month, I would still owe the $1,200, the principal amount, because I never paid anything towards decreasing my principal. So for the life of this loan, if I only paid $12 a month forever, I would never pay off this loan. But let's suppose a different scenario. Instead of paying just $12 a month, I want to pay $200 a month towards the principal, plus whatever the current interest is at the end of each month. So we're going to fill out a table to see how many months it would take us to pay off this loan. So let's look at the first part of the table. Okay, so in this table, I have 6 columns. The first column is the month 1, month 2, month 3. The second column is the principal, the prior principal. Third column is the interest on that prior principal. Fourth column is the payment towards the principal. How much money in my payment is going towards the principal. This is how much money is going towards the interest. So my total payment would be $212 at the end of that first month. Because I'm going to put $200 towards the principal, I have to pay the $12 in interest that has accrued on that $1,200 principal. So that total payment of $212 at the end of month 1 would give me a new principal balance of $1,000. Now on month 2, we would calculate the interest, and we'd write down the payment towards the principal, and keep doing this until we get down to no money left, a zero balance. So work on the next columns, or actually rows. So let's take a look at the next row for the end of month 2 when you make your payment. So now your principal isn't $1,200, it's $1,000. The interest on $1,000, since it's 1% monthly, is $10. So I'm going to have to include $10 in my payment towards the principal. So I'm going to keep paying $200 towards the principal. My payment this month would be $210 to cover the $200 towards principal plus the interest that I have to pay. So now my principal is $800. I knocked $200 off of the principal. So starting principal on month 3 is $800. The interest on that is $8. And if I'm putting $200 towards my principal, then my payment's going to be $208, knocking another $200 off of the principal amount that I owe. If you continue this way, you'll end up in month 6 paying a payment of $202, and you would have a zero balance at that point in time. Now, the type of loan that you pay off with equal regular payments is called an installment loan or an amortized loan. Those equal payments, you may think of that as maybe a car loan or a mortgage, maybe not necessarily a credit card payment, because that gives you a minimum amount due, but you should always pay more than that. But the type of loan where it says you owe $188 a month for 36 months, that's an installment loan. And these payments, when you're working with an installment loan, portions of the payment goes towards the principal and portions of that payment go towards the interest, and it varies as the loan is paid down. So let's go back to that $1,200 a month, $1,200 loan, and I want to pay it off in 6 equal monthly payments. So instead of paying $212 and then $210, $208, $206, and so on, I want to find out what that equal payment would be. Maybe I want to make sure I have all the money in my budget, and I don't want that value to vary. So I know if I were to pay this off with equal monthly payments, the payment would have to be somewhere between $202 and $212, because that was the high and the low values for that 6-month payment. Well, to figure out what the equal monthly payments would need to be, we need a formula. So we have a brand new formula to work with. It's a big one, but you don't need to memorize it. Okay, so working with installment loans, we've got a loan payment formula, or an installment formula if you wanted to call it. Variables are similar to what we've seen before. P is our loan principal. Now payment, the PMT, is what we have on the left-hand side. That's what we're trying to find. We want to find our loan payment. What do I have to pay each month on this loan? So we see APR, we know the annual percentage rate. N is the number of payments you're going to pay per year. So N is pretty much going to be 12 because you make 12 monthly payments. Y is the number of years you'll be paying on that loan. And I think those are all the variables. So we can work on finding the payment. Also, the number of years needs to be, or I should say this, if we're working with the number of years, 6 months represents a half of a year. So we would use 1/2 to represent the number of years, which was what we are about to do. So let's go back to that problem where we had the starting principal of $1,200, APR of 12%. I want to pay this off in a half a year, and I want to figure out what are the 6 equal monthly payments I would need to pay this off in 6 months. So writing that formula down, and again the same thing applies, don't round until your final result. Make sure you write the formula correctly, exactly as it's written above. I have it written here. And so we'll go in and sprinkle in those values. 1,200 for P, 0.12 for APR, 12 for N, 0.12 for APR, 12 for N. This exponent would be a -12 times 1/2 for the number of years. We also have to remember the order of operations. Make sure you handle what's inside those parentheses or grouping symbols first. then take care of some exponents, and then add, subtract, as we did in previous problems. Don't round till you get to the end. And so the payment on this $1,200 loan, 6 equal monthly payments, would be $207.06. Remember, we knew it was going to be around 202 and 212 because that was our high and our low that we did earlier. But these are the equal payments to pay it off. Now, when you're working with a loan, early in that loan, the largest portion of your payment goes towards interest. That's relatively high. And the portion of your payment that goes towards the principal is pretty low. Now, as the term of the installment loan proceeds, this pattern gradually reverses. And towards the end of the loan, most of your payment goes towards the principal and relatively little of that payment goes towards the interest. So let's use this formula again and calculate repayment of a student loan. So we have a student loan, we have student loans, I guess this says, totaling $7,500 when we graduate from college. The interest rate on this loan is 9%, and the loan term is 10 years. So we want to find out what are our monthly payments. Let me pull this down a little bit. So we want to find our monthly payments, and then once we determine our monthly payments, we want to figure out how much I'll pay over the lifetime of that loan. And once I know what I've paid for the lifetime of that loan, how much interest did I actually pay on that loan? Basically, it's what the bank charges for loaning you that money, the interest. So I'm wanting to find a payment, so I'm going to use this loan payment formula. So I would rewrite that formula down exactly as it was written above. PMT is equal to big division in the numerator, principal times parentheses APR divided by N. In the denominator, set of grouping symbols, 1 minus, in parentheses, 1 plus APR over N raised to the negative NY power. So let's sprinkle in the $7,500 for principal, 0.09 for APR, 12 for N, and 10 for Y. Use your calculator, do one little piece at a time. The numerator is 56.25, and the denominator is 1 minus 0.407937305. Making that final division, we get a monthly payment of $95.01. So on the $7,500 loan, I'll pay $95.01 every month for 10 years. So the question is, how could I figure out what will I pay over the lifetime of this loan? Well, we have all the information we need here. We have the monthly amount. So we've got our monthly payment here, $95.01, and that's going to be paid every month for 10 years. So it would be $95.01 times 12 times 10 to give me what I would pay for over the lifetime of that loan. Well, that ends up being $11,401.20. So that's what I end up paying back for the $7,500 loan. The question is, how much of that $11,401 is actual interest? So if I take the $11,401.20 and subtract $7,500, the actual principal that I borrowed, that'll give me $3,901.20, which represents the interest I would be paying on that loan. So that's basically, I'm giving the bank $3,900 and saying, thank you so much for letting me borrow your money. Let's wrap up this first video with this last example. We're going to take that $7,500 loan that has 9% interest, and a monthly payment of $95.01. And we want to calculate what portions of our payments for the first 3 months goes towards principal and what portion of that payment goes towards interest. So I'm paying them $95.01, but how much of that is interest and how much is going towards my principal? So I sort of devised a table like we saw earlier. First column is months, second column is my principal, third column is my interest on that principal, but this is a little different. Once I know the interest that I'm charged, I'm going to subtract it from my payment, because when I do, that's going to tell me how much of my payment goes towards principal. So the number that I have in this last column represents the amount of my $95.01 payment, how much actually goes to reducing my principal. So for month 1, my principal is $7,500. Now, remember, in our earlier example, we multiplied by 0.01 because that was a 12% interest divided by 12 months. Well, here we have a 9% interest divided over 12 months, and 0.09 divided by 12 is 0.0075. So I'll take the 7,500 times the 0.0075, and that's going to tell me how much interest I'm paying that first month. Well, if the interest is $56.25, I'll subtract that from the $95.01 payment to find out how much money is actually going towards the principal of this loan. When I subtract them, I see that $38.76 of my payment goes towards the principal. So that means my principal is no longer $7,500, but it's $7,500 minus this $38.76. So for month 2, my principal has been knocked down to $7,461.24. That's the new principal I'm working off of. Now I'll multiply it by the 0.0075 to figure out how much interest I owe on that excuse me, on that principal, and the interest is $55.96. Well, if I subtract that from my payment that I make of $95.01, I find out that on month 2, the amount of principal, or the amount of money that is being paid towards my principal, is $39.05. You'll notice here in this third column that those principal values, principal payments, continue to get higher while the interest payments will get lower. All right, well, I'll stop it here and upload it and then continue.